Hello guys, today's lecture is the machine learning lecture. In this lecture, we will talk about the machine learning, mathematics for the machine learning with applications. There are three parts will be covered in this all over the course in this lectures. These lectures consists of I think so lecture 1, lecture 2 up to lecture 16. We will cover all the course uh, from the 16 lectures and 4 weeks. Therefore, you have to learn about the concepts and implementations of the machine learning algorithms by using the Python, and I will talk about the coding section also. At the end of this course, you will be able to do the project of the machine learning, in which you will learn practically how to things implemented practically. Let's have we move to the next slide. The lecture 1 outline. In this lecture, we will cover the course information, what is learning, why machine learning, categories of machine learning, relationship to other fields, and application of the machine learning. Now we talk about the term of the why machine learning is important. Why we study the machine learning. Tasks that are too complex to program. Basically, the task performed by the human like drawing and speech recognition are difficult to elaborate. Tasks that are beyond the human capabilities. Basically, we have discussed in this section why the machine learning is important in our life, how to tackle the things by using the machine, and it's being used in the domain of AI, artificial intelligence. Basically, machine learning plays an important role in the artificial intelligence, in which the things are being processed automatically. The robotics are the best example of the AI. Analysis of very large and complex data sets, astronomical data, turning medical archives into medical knowledge, weather predictions. These are the examples of the how to apply these terms via the machine learning. And the next, the tasks change over time or from one user to another. Typically, successful applications of the machine learning to such problems include programs that decode hard written text. Machine learning is the traditional computer science program computer for every task. In this area of the machine learning, we program to the computer to perform the specific task. New paradigm provide example to machine learning. Machine learns to accomplish a task based on the examples. Just like in the picture, you can see that the uh, you can see that the squares in a green color that represents when you going on the road, you will observe the things around you. Machine learning definitions, there are two definitions. You can see that the machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. The other definition, a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improves with experience E. A common task. Machine learning algorithm learns to combine input to make useful predictions for never before seen data. Basically, in this term, we have talked about the machine learning algorithm. You know, the algorithm is the sequence of steps in which we program anything else. The algorithm takes features. All the algorithms take some inputs and produces some outputs. The features, the labels. The algorithm task covers the features and the labels. The input consists of the examples, labeled input, spam email, unlabeled input, labeled to be predicted. Model trains and falls. Machine learning relationship to other fields. You can see that there are five circles. The large circle is the machine learning. You can see that the artificial intelligence domain also we discuss the machine learning. In statistics, we will also talk about the machine learning. We have to apply the statistics abilities of the applying in the machine learning domain. Optimization is another thing in which the machine learning being applied, and finally the algorithm and complexity also the part of the machine learning. In this picture we can see that the relationship to other fields. Artificial intelligence, ability of the machine to imitate intelligent human behavior. Machine learning, application of the AI that allows a system to automatically learn and improve from the experience. Another thing, the deep learning, application of the machine learning that uses complex algorithms and deep neural nets to train a model. Categories: supervised learning, unsupervised learning, reinforcement learning. Training data comprises examples of the input vectors along with their corresponding target vectors. This is the supervised learning. Unsupervised learning, training data consists of the sets of input vectors without any corresponding target values. This is the unsupervised learning. The third part of the learning is the reinforcement learning, problem of finding suitable actions to take in a given situation in order to maximize a reward. Supervised learning, More formal, inductive learning for supervised learning. Given a training set of example of the form x f of x. In this scenario, x is the input, f of x is the output. Returned in a function h that approximates f of x. H is called the hypothesis. Supervised learning. Two types of the problems. Classification. Aim is to assign each input vector to one of the finite number of discrete categories. Regression. If the desired output consists of one or more continuous variables. The nature, categorical or continuous, of the domain input space of f does not matter. You can see that the x goes to be the function of f, classify, and y belongs to +1 to -1 label. This being used the binary classification, fraud detection, credit card transaction, fraud or not fraud, toxic comments, online comments, toxic or not toxic, regression. X going to the function of f, y belongs to real number, the response is poverty mapping, satellite image asset weather, the wealth index, housing, information about the house price. Binary classification examples, problem which you enjoy outdoor sport based on the weather. How to predict the weather condition. Training sets is the sunny, humidity normal, strong wind, warm water, and forecast same, enjoy sport, yes or not. The last column of this table, enjoy sport, is the ffx function. Possible hypothesis, h1 is the sky, sunny to enjoy sports, yes. H2, water cool or forecast same, enjoy sports, yes. Regression example, problem find function h and fits f at instances x. We have to observe in this slide the relationship, why it will be the linear relationship or not the linear. You can see that in this slide the red line represents the linear relationship. The green line, you can see that it's not a linear relationship. The blue line also is not the linear relationship, and this is the yellow lines also not represent the linear relationship. Multi-class classification example, digit recognition, postal code. You can see that the simplest approach, memorization. When we talk about the image recognition, we have to apply the practical example in which we run the program on the data sets. If we didn't apply the data set, then our machine will not be able to detect it. This is the digit recognition, postal code, nearest neighbor, multicast classification example. You can see that in this slide the database is 60,000 images we can input to the machine. Generalization key. Good hypothesis will generalize well, predict unseen examples correctly. Prefer the simplest hypothesis consist with data. Generalization make machine learning existing and difficult. More example. ImageNet classification. In this slide, the categories of the 40 million images and 22K categories. In this slide, we can see that the animals are the birds, fish, mammal, and the plants, tree, flowers, food materials, structures, tools, appliances, structures, persons, indoor formations, sport, archi, arch- This is the ImageNet classification. Large scale visual recognition challenge. The image classification challenge 1000 object classes and a lot of images. You can see that in this picture output scale t-shirt, steel drumstick. Output will be the scale t-shirt, gain paradise and the drumsticks. Large scale visual recognition challenge. Deep neural networks. You can see that in this picture. The year 2010, year 2012, year 2014, year 2015. You can see that the observations. In this scenario, real world challenges. Image classification is a common task in a computer vision. Assume given sets of discrete labels: dog, cat, truck, plane. This is the cat. The problem? Semantic gap. When the computer understands the 0 and 1 only. An image is just a big grid of the numbers between 0 and 255. The RGB, the colors of the combinations 800 into 600 into 3, because the 3 channels of the RGB in this scenario. Now the real world challenges. Viewpoint variation, the camera variations. The pixels change when the camera moves. The pixel change when the camera moves. And also the predictions of the pictures of the image recognition will also be changed. Here, the real world challenges. The illumination and the deformation. You can see that the pictures, the how to differentiate the illumination and deformation, but the computer didn't understand it. We have to learn about these pictures through the machine learning to the computer. This is the another example. Occlusion and the background clutter. In the background clutter, we didn't see clearly the picture of the cat. In this scenario, the above the occlusion is the cat behind the grass, and we didn't see it. How to talk about the machine learning to see the cat? Here is the intra-class variation. There are a lot of the cats. How to differentiate by the computer via the approach of machine learning. Unsupervised learning. Output is not given as the part of training set. Find model that explains the data, clustering, visualization, dimension reduction, density estimation, compressed representation, features generative model, clustering. Find nature grouping of the instances given on unlabeled data. You can see that in the x-axis and y-axis some of the dots. 2 is the original input compressed representation. 2 is the original input given to the encoder and it converts into compressed representation and goes to the decoder and convert into the reconstructed input. This is the encoder trained on large number of images. We can see that here the diagonal line node and the face node and the cat node. These uh, images are combined and picture make the cat easily by using the machine learning. Reinforcement learning. What is the reinforcement learning? Policies. What actions should an agent take in a particular situation? Utility estimation. How good is a state used by the policy agent? Environment. State. Reward is the input and output will be the action. Goal. Learn to choose actions that maximize rewards. Reinforcement learning. Animal psychology. Reinforcements used to train animals. Negative reinforcement. Pain and hunger. Positive reinforcement. Pleasure and food. Let's do the same with computers. Rewards. Numerical signal including how good actions are. Game, win, loss, robotics, autonomous vehicle. Game playing. Example Go, one of the oldest and the hardest board games. Agent, player, environment, opponent, state, board configuration. Action, next turn, location, reward, plus one win, minus one lose. This is the example of the reinforcement learning. Machine learning applications, speech recognition, natural language processing, computer vision, robotics control, intelligent assistance, computational finance, stock trading, portfolio optimization. This is the end of our today's lecture. Do you have any question? You will free to talk about me. Thanks for watching. Like and subscribe my channel.